Welcome to The Explainer. We're here to break down the big ideas that shape how we work. So let's just dive right in with a question that I'm sure keeps a lot of us up at night. Why does it feel like every single software project is in a constant battle with the calendar? This has been a source of stress and, let's be honest, a lot of broken promises for decades.
Ah, yes, the classic developer response. We've all said it, we've all heard it, and while it's a great line for a business, when it's done just doesn't cut it. You can't plan, you can't budget, you can't make smart decisions without some idea of the future.
Well, back in 2007, Joel Spolsky got fed up with schedules that were basically works of fiction. He came up with a system he called evidence-based scheduling, or EBS. The goal was simple: create schedules people could actually believe in. But the big question for us is, does a system from 2007 still make sense today?
Okay, here's our game plan. First, we'll look at why schedules fail in the first place. Then, we'll unpack Spolsky's data-driven solution and its 4 main steps. We'll see how it handles real-world chaos, and then we'll get to the big one. What's the payoff, and is any of this still relevant now in our world of agile and remote work?
All right, section 1, let's really dig into the root cause of the problem that Spolsky was trying to solve. You know, Spolsky really nails it. He says developers hate making schedules for 2 simple reasons. 1, it is a huge pain. And 2, even after all that work, nobody, not the developers, not the managers, actually believes the dates are real. And that kicks off this vicious cycle where the schedule gets ignored until, of course, the project is late. And that leads to huge business problems, like having no clue which features are actually worth building. So if the old way of just, plucking a date out of thin air is so broken, what's the alternative? This is where Spolsky's idea comes in, and it's a completely different way of thinking. So here's the big idea. Evidence-based scheduling throws out all the wishful thinking. Instead, it relies on cold, hard evidence, your team's actual historical timesheet data, to predict the future. This means you stop talking about one single fragile deadline and start talking about a much more honest range of possibilities. So instead of your boss saying, "We need this by October 26th, you get a picture that looks something like this. This curve shows the probability of shipping on any given day. If you see a really steep curve like this one, it means you've got high confidence. But if the curve is low and spread out, that's a huge red flag telling you there's a ton of uncertainty in your schedule." Okay, so that's the theory, but how do you actually do it? Let's get into the nitty-gritty of how you build one of these schedules. Spolsky lays it all out in 4 pretty straightforward steps. You start with good planning, then you move to tracking. You use a little bit of math to look into the future, and finally, you use the schedule as a tool you look at every single day. Now, this first step is everything. You can't estimate a giant fuzzy task like build the new photo editor. That's just a guess. But you can estimate something small and concrete like write the file parsing subroutine. By forcing every task to be small, you're secretly forcing yourself to actually think through the design. And that is the key to any good estimate. Step 2 is tracking. And this is where we get the secret ingredient, velocity. Now, this is super important. Velocity is not about how fast a developer codes. It's not a performance metric. Think of it more like a personal calibration factor. It's just your original estimate divided by the actual time it took. And this little number is incredibly powerful because it captures how you personally tend to estimate things. And once you start tracking this, you see these amazing patterns emerge. You've got your perfect estimator, a true mythical creature. Then you've got the bad estimator, who's just completely unpredictable. But most of us, if we're honest, fall into this last category, the common estimator. We're pretty consistent, but we're consistently optimistic. EBS uses that personal history to automatically correct for our natural biases. Okay, this is where the magic happens. It's a technique called a Monte Carlo simulation. Now, don't let the fancy name scare you. The concept is really simple. Instead of just one plan, the computer runs your project plan thousands of times. For every single task, it picks a random velocity from that developer's actual past performance. You run thousands of these possible futures, and that's what builds that beautiful, realistic probability curve we saw earlier. All right, this all sounds great in a nice, quiet lab somewhere, but we all know that's not the real world, right? What happens when you get interrupted or pulled into a last-minute meeting or someone has a great new idea? Spolsky gives us this perfect and, let's be honest, painfully relatable example. We all have that thing that just derails our focus and destroys our schedules. So his solution is a little weird at first. He says when you get interrupted, just let the clock keep running on whatever task you were working on. I know, it sounds crazy. Why would you build time talking about phishing to the feature you're trying to code? Well, there's a really brilliant reason this works.
See, here's the genius of it. Because you've always been letting the clock run during interruptions, your historical data is already full of them. Your velocity already accounts for the real world. So when the simulation runs, it automatically bakes in the statistical chance that you're going to get interrupted again in the future. The system literally learns your environment, phishing stories and all.
So that's how you handle interruptions. But what about scope creep? You know, those little, oh, just one more thing requests? For that, Spolsky gives us this fantastic metaphor.
This makes the trade-offs painfully clear to everybody. Think of your schedule as a box and your features as blocks. If a new block comes along and it doesn't fit, you have exactly two choices. You can get a bigger box, which means you push the ship date, or you can take some other blocks out, which means you cut features. The one thing you are not allowed to do is pretend you can magically shrink the blocks to make them fit.
So why on earth would you go to all this trouble? Well, because the payoff is huge. It's not just about hitting a date, but how we use this idea today has definitely evolved. See, a realistic schedule is actually a strategic weapon. It forces you to have those tough conversations about what's really important before you've spent months building the wrong thing. But here's the modern twist. Spolsky's original idea focused on individual developers. Today, we know that can create a culture of fear. So smart teams now apply this philosophy at the team level. They use data from tools like Jira to forecast the team's throughput, not to micromanage individuals. It's about creating psychological safety so people can be honest, and that's what prevents burnout and lets everyone go home on time.
And really, that's the ultimate question that evidence-based scheduling in any form forces you and your team to answer. It turns scheduling from a stressful guessing game into a powerful, strategic conversation about what's truly worth your time. So, what do you think? Is evidence-based scheduling still relevant? Let us know in the comments how your team handles estimates. If you found this breakdown useful, go ahead and hit that like button and subscribe for more deep dives into software development and project management. Thanks so much for watching, and we'll see you in the next one.